Hi guys! The purpose of this video is to review goal number 4 with you, which is distinguishing the difference between the heat and temperature of a substance. We have this table here for you to just recap the definitions of each and what each depends on. So for heat, just to remind you, is that heat is the total kinetic energy or the total speed or molecular motion within an object, whereas temperature is more so just the average kinetic energy or the average particle speed of a substance. With heat being the total, it's dependent on multiple things. If you're looking at the total of something, specifically the total heat within an object, it depends on the speed of the particles. It also depends on the amount of particles or the mass of the object, as well as the type of particles, for instance, if it's an insulator or a conductor. Temperature is more so dependent on simply the speed of the particles because it's the average speed of the particles. So it is not dependent on the number of particles or the mass, or also even what type of material it is.
So looking at a couple of scenarios, we're going to start with this scenario here. We have an igloo and a single burning match. And if in a scenario like this, you were asked to compare the two substances' temperatures, you'd want to consider how fast or how slow the particles are moving within these two substances in order to determine which one has the higher temperature versus the other. So in our scenario here, and comparing the igloo versus the single burning match, the single burning match has a higher temperature because on average, those particles are moving at a much quicker rate than the particles within the igloo. But if we were to ask you which one has more heat between the igloo and the single burning match, you'd want to consider the size of the two objects. So thinking of the size, the igloo is much greater in size than the single burning match, and therefore it has more molecules than the single burning match. And because it has more molecules than your match, it has more total heat than the match. So it has more particles, even though those particles are not moving as quickly as they are in the match, because there are more of them, if you were to add up their individual speeds, it would total more motion, more kinetic energy than the match. And therefore it has more heat. So in this case, igloo has more heat because it has more particles.
Looking at a slightly different scenario, we're going to keep our igloo in this scenario, but instead of comparing it to a very tiny match, we are going to compare our igloo to a dumpster fire, and the dumpster is relatively the same size as the igloo. So if you are comparing these two objects, you would notice that the size of them is relatively similar. They're about equal. And because they have about the same amount of particles, that's not really as much of a factor that is going to be considered when you're comparing which one has more heat. So because the size is the same, we're going to focus then next more so on the temperature of the objects, or looking at the average speed of the molecules. So if we were to look at the igloo is at a lower temperature, and because of that, it has slower moving molecules. Its speed of the molecules is slower. So even when you add up all of the individual molecules, it will have less total energy than the molecules in the dumpster or the dumpster fire because the molecules in the dumpster fire are moving much quicker. So because it has the same amount of molecules and the molecules are moving faster, the dumpster fire would have more total heat than the igloo in this scenario because of its size. The size is the same, but now you're looking at the speed of the molecules as well. So because the size is the same particles, you now have to really focus on the heat.
So that's all for you guys. Thank you for watching.